Now we're going to look at resistance. In the syllabus it says that students should be aware that R is equal to V over I. It is a general definition of resistance. It is not a statement of Ohm's law, and students should understand what is meant by a resistor. So basically, what is resistance? And to describe it roughly, it's the measure of how a component impairs the flow of current. The bigger the resistance, the more the current is resisted, it's impaired. And it depends on the design of the resistor, the cross-section of it, and so on. But this gives a description of what a resistor does. It doesn't give the definition. You need to know the definition. The definition of resistance is using the equation V is equal to IR, or in other words, R is equal to V divided by I. This defines resistance. In an exam question, you must define it this way and define V, which is the potential difference, and I, which is the current. So there we have it. The resistance is measured in ohms. So this means if a component has a high resistance, if this value is high, with a given voltage, a given potential difference, the current will be low. So, the definition. The resistance is the potential difference divided by the current for a component. Some examples. The human body has a resistance of between 100,000 ohms and 1,000 ohms when it's wet. Try to find the current when you hold a 12 volt connector to let's say a car battery. What would be the current then? So you do the current is equal to V divided by R, and so it's going to be 12 divided by 100,000, so the current will be very small. Even 12 divided by 1,000, the current will be very small. And in theory, if it's around 1 milliamp, you should be able to feel that. 10 milliamps, you would feel that, and it would make your muscles contract. It's said that 100 milliamps can be fatal. It depends if it goes through the heart or not. So, knowing this, what is the voltage that will kill you? Your body has a resistance of 1,000 ohms or 100,000 ohms when you're dry. Find the voltage that will kill you. V equals IR. The electrical resistance of a wire. What does this depend on? It depends on basically two factors. It depends on the length and the cross-sectional area and the type of metal it's made of. So we have to be able to apply this equation. The resistance is equal to rho, which is the resistivity, how resistive that material is, the length, and divided by the area. So the resistance of the material is increased if the material is longer, since each length of the material through which the charge must pass contributes more resistance. It's like going up a longer slope or a bigger hill. The bigger it is, the more resistance overall it supplies. So we know that the resistance is proportional to the length. Also, it's decreased if you have larger cross-sectional area, since there are more possibilities for the current to flow through the wire. Compare a narrow road where the traffic cannot flow, compare a narrow road where the traffic can flow with a very wide road where traffic can flow. So basically, the larger the area, the smaller the resistance, the more traffic can flow, the more current can flow. Resistance and resistivity. So we know the resistance is proportional to length. We also know that resistance is proportional to 1 over A. In other words, it's inversely proportional to the area. So if we combine these together, we can say that R is proportional to L and proportional to 1 over A. So we say R is proportional to L over A. But we can introduce a constant here. R is equal to constant times L over A. And what is this constant? This constant has something to do with the quality of the resistance, the resistor. and we call this the resistivity, and it's given the symbol ρ. So R is the resistance in ohms, ρ is the resistivity, which is in ohm meters, L is the length of the wire, and area is the cross-sectional area. We have to be able to state Ohm's law. Ohm's law is not V is equal to IR. Ohm's law basically tells us that for a particular resistance, the voltage is proportional to the current, or rather the current is proportional to the voltage. In other words, a resistance will have a constant resistance provided the temperature stays the same. So Ohm's law is not V is equal to IR, because this is the equation that it's used to calculate resistance. Ohm's law is this: the current through a conductor is proportional to the potential difference across it, provided the temperature is kept constant. And we can draw a graph like this. This is changing the potential difference, and the current will change accordingly. What we notice is that we have a straight line graph through the origin. We can say that the current is proportional to the potential difference. Another thing is that if you double the potential difference from 4 to 8, you will double the current. This is another characteristic of proportionality. Another way of looking at it is the ratio between the potential difference and the current will always be the same: 4 over 1, 8 over 2, 12 over 3. So Ohm's law says that the resistance, which is V over I, 12 divided by 3, 8 divided by 2, 4 divided by 1, will always be the same value. So the resistance will be constant whatever the potential difference, whatever the current, and this is Ohm's law. So this resistor is ohmic. We have to compare ohmic and non-ohmic behavior. So we have to draw an IV characteristic of an ohmic resistor and a filament lamp. So the ohmic resistor we've just looked at, this is a filament lamp. It starts off straight and then starts to curve over. We can see that it's ohmic to start with. If you double the potential difference, you double the current. But it doesn't always work this way. It's only proportional up until about 6 volts. So this part of it is ohmic, but then afterwards this is non-ohmic behavior. So what happens, the resistance changes. So you basically, with a greater voltage, the current is a little bit less than it would expect. So you get a smaller increase in current with respect to the potential difference. In other words, the resistance increases. At high potential difference, where the current is large, there is less current than expected. So the reason for that is that the resistance has increased. Why does the resistance increase? Well, it's a non-ohmic resistor, and the reason for it is that in a filament lamp, the filament heats up, and this new temperature will affect the resistance of the wire. Why does the resistance increase? Well, when the temperatures increase, the particles inside the metal are vibrating much more, and they impede the flow of electrons. Derive and apply expressions for the electrical power dissipation in resistors. We know the power is equal to energy divided by time. We can express it this way. We can also say that energy divided by charge times by the charge over time. This is the same thing. But we know that energy over charge, the joules per coulomb, is the potential difference. We know the charge flowing per time is the current. So we can say that the power is the potential difference times by the current. Power is equal to the current times the potential difference. Now, you know the power is equal to potential difference times current, which is equal to V times I. But you know that V is equal to IR. We substitute IR into here. We have P is equal to IR times by I, gives us I squared R. This is showing the power in a wire, if you know the current, it's going to be I squared R. This is important. This is called the power loss in a wire. It means that when you have a certain current, the wire will heat up, and this large current causes this power loss. In other words, energy is lost to the surroundings because the current makes the wire heat up. On the other hand, using the same equation, V is equal to IR, we know that I is equal to V over R, and we substitute that into P is equal to IV. So P is equal to V times I. We know that I is equal to V over R. So we also have power is equal to V squared over R. And this is another useful form of electrical power. When we do Unit 12 for a higher level, we realize that when you have a high current in a wire, it's not good for transmitting electricity because the wire will heat up and you will lose a lot of energy. We will look at that again in Unit 12.